the hearing capability really matters. And ironically enough, women are excellent at hearing. Like my wife can hear literally, like our audio system in our house is fully active. So we've got no passive crossovers. Everything is digital DSP. Like I built everything from the ground up. It's a pretty skookum system. Even though it's fairly small, there's a lot of control over it. And she can hear 0.1 of a millisecond delay.
Really? Okay.
Difference.
She can also
hear that.
She can also hear all those comments you make under your breath in the other room. Yes, they've got like radar ears. They sort of move around, and then of course they're super like bionic woman ears. But anyway, that's another story. And welcome back to Not an Audiophile, the podcast, episode 20, season 2. I'm Andrew Hutchison, and today we're speaking to Cody Hebert from Canada, a subwoofer manufacturer of exceptional quality, or a manufacturer of subwoofers of exceptional quality, or perhaps both. This episode of Not an Audiophile is sponsored by StereoNet. Are you looking for your tribe? Visit stereonet.com today to join one of the world's largest online communities for hi-fi, home cinema, headphones, and much more. Read the latest news and product reviews or check out the classifieds for the largest range of gear on sale. Membership is absolutely free, so visit stereonet.com and join up today. Today, Not an Audiophile, we have Cody Hebert from Alberta. Clearly, you've had jobs other than the one you currently have, which is running, designing, manufacturing, whatever. And you'll tell us about what role you have at Harbottle. But I believe that you started the business. Is that the gist of it?
I did. I am the CEO. And did you ask about my previous jobs?
They were in the audio industry, I'm guessing. Or not?
No,
is that right? Okay, then do tell. Do tell.
I'm a tradesman. I started work at a very, very young age, almost illegal to work.
Yes.
And come from very blue collar roots. And I got into the piping trades. So I got I think it was like 3 journeyman tickets.
And is this what we would call plumbing, as in you
plumbing, pipe fitting, gas fitting.
Oh, and gas fitting as well. HVAC. Yeah, okay.
Yeah. And HVAC.
Yeah, okay. All right.
So air conditioning.
The refrigerant style. Yeah.
The refrigerant stuff.
Yeah, okay.
And in that process, I started up my own company. And I kind of started things off from more of like a company building aspect. And I found that I really liked building companies. I thought, hey, this is kind of cool. This is fun.
It is. And
I started advising small companies.
Okay.
And I got hooked up with I diverged from the plumbing trades or the pipe trades into welding and fabrication.
Okay.
And so I was actually fabricating with a crew. We were fabricating luxury yachts in British Columbia.
Rightio. Yeah. Sounds cool.
It's a wild story. And one of the guys on the crew, his brother owned a fledgling audio company. And he told me that his brother was looking for some help, getting his company launched. And he saw what I could do in the shop just from like an organizational standpoint and, making things efficient and all of that. And we got introduced and I started working. Well, his brother hired me. His name was Nathan. His brother hired me and I kind of approached the whole thing from, well, if I need to build this company, I need to know as much of it as possible.
Sure.
And through the piping trades, I diverged a couple of times. I went to university and for engineering, and specifically structural engineering.
Mm-hmm.
And I took my ability to work with companies and I applied it to, how things are made. And I just started, absorbing as much as I could about audio. And because this fledgling little audio company showed some real promise, and I was a musician ever since I was really young. I was playing music,
Okay.
and I took a liking to the drums. And
So not really,
I was
never,
never
not really a musician then. That's the old joke, right? Which I shouldn't have brought up, really. Yeah. What is it? What's the
no, you are correct. I've heard some pretty horrific drumming. So.
Oh yeah. That would probably have been me. Zero rhythm.
I took a liking to the drums and I started teaching myself, and everything that I did in music was all self-taught. And my father had perfect pitch, so he can hear something and know exactly what it is and dial into it. And so I never had any schooling for music, and I just started learning and really grappling with things. And I took all of that and I combined it into learning as much as I could about audio. And it turned out that I was actually pretty good. And I snapped into learning, magnetics and speaker drivers and, electromechanical magnetic, structures. I adapted to it really fast, like stupid fast. I don't know how I did it, but I did. And yeah, I just started taking what I learned from building this company and I turned it into my own approach. And so Nathan and I still actually work together.
Okay.
And we constantly bounce things back and forth. And through that process, I built Harbottle Audio, and I am the chief engineer and I am the CEO. And we specialize in bass systems.
Yeah, and that's an interesting thing. And what's interesting is that your background, your skill at drumming means, or your experience at hearing what a drum actually sounds like, sets you up well for how the hell a bass system should work. Because by rights, to some degree, you would think if you got everything right that drums or lower frequencies may be easier to reproduce in a way that you could fool the human to believe that it was live music. But is that the way you feel about it? I mean, clearly most bass systems don't get things right. I mean, to have the amount of the pace, the impact, the dynamics, the lack of distortion is actually harder to get it. Obviously, at bass frequencies, there's much more energy involved.
Definitely.
But it's, I don't know. It's I don't know. I think I've lost my point now in a way. But the fact is that you know what a drum sounds like, and that's a great start, because I sometimes wonder whether half the people in hi-fi have ever even been to a concert. But moving right along. So the other firm, do you wish to mention Nathan's business as well, or is it not irrelevant at this point? Or I mean, he's still trading. Obviously, you were saying that you.
He's still trading. We're the primary partner. We call ourselves like divorced partners. So he has his own company and I have my own company.
Okay.
And most of the work goes through Harbottle, but he does a lot of really high-end custom audio systems. And his company is called Funk Audio, F-U-N-K Audio. And he's also located here in Alberta as well.
Oh, okay. Right.
And what you were saying about drumming is, I know exactly where you're going with that. Drums have a couple of components. The attack is extremely dynamic. So when the mallet hits the skin, that skin is called the batter. And the batter is extremely dynamic, but then the shape of the drum itself, the shell, It also on the bottom end has what's called a resonant, and that resonant does exactly that. It resonates along with the shell.
Mm-hmm.
And so it produces a follow-up sustain. And so it has two things in it.
Yeah.
And you can actually relate them directly to amplifier power.
Mm-hmm.
The attack on the batter, that is peak output.
Yeah.
So that's a peak, hit it, bang.
Yep.
Right? And then the follow-up sustain, that's RMS power.
Yes. Yeah.
So that in order to create the sustain for as long as it needs to be created for, a speaker driver has to be able to do both at the same time while creating other frequencies at the same time. And that's where bass gets extremely complicated, because the rate of change below 100 to 150 hertz, it's kind of a great area. The rate of change from 100 to 150 hertz down into infrasonic is extremely exponential.
Yeah.
But it's exponential also in a way where the rate at which a person hears is also changing exponentially as well. So the audibility of bass starts to change a lot, and the sensitivity of the individual. So the hearing capability really matters. And ironically enough, women are excellent at hearing. Like my wife can hear literally, like our audio system in our house is fully active. So we've got no passive crossovers. Everything is digital DSP. Like I built everything from the ground up. It's a pretty skookum system. Even though it's fairly small, there's a lot of control over it. And she can hear 0.1 of a millisecond delay.
Really? Okay.
Difference.
She can also
hear that.
She can also hear all those comments you make under your breath in the other room. Yes, they've got like radar ears. They sort of move around, and then of course they're super like bionic woman ears. But anyway, that's another story. No, that is my experience as well. And sometimes people think I'm not being completely serious, and sometimes customers mention this as well, that they've changed something in the system, and their partner, often a woman, is in another part of the house, and is like, "What have you changed? What have you done? What is something that sounds better." Well, it sounds better in the other room at least, but yeah, they are. I was going to say they're great listeners. Maybe they are, but they certainly have very sensitive hearing. Maybe they don't. Maybe their hearing doesn't cop the industrial hiding that the male hearing does in many cases. Or maybe it's just the way they are. They are more sensitive creatures generally. I've heard. I don't know that that's true. So anyhow, you use your wife as a reference for subtle improvements.
Oh yeah. Like she's got abilities that I don't, and one thing I've learned in business in general is if you want to get the best out of something, you have to put your pride aside, and you have to give credit where credit is due. In that there are other people that bring something to the table that it's not that it needs to be recognized for the sake of, putting people up on a pedestal or anything like that, but it's an acknowledgement of where the process starts, and then relating that to the end result. And in business, I find that that's just a really good practice. It lends to transparency. It lends to really good business ethics and acumen. And over time, the reputation builds. And my reputation is one, somebody that is, focused on fidelity, number one.
Yeah.
The end result of the user is attached to that fidelity, and then just really good customer service. But that also breaks down into how transparent we are with projects and what the person is going to get. And when I say to somebody, hey, listen, you're over designing this subwoofer is going to smoke anything that you've ever had, and it's going to be intensely loud, and they come back to me and say, yeah, you're right, this thing is a beast. We deliver exactly what is stated on the website. exactly what we state in our policies, and acknowledging all the people that are a part of that recipe leads to an excellent dish that's palatable for everybody. Because ultimately people are looking for um, a product or an experience when they're buying anything that makes them comfortable,
Yeah.
but also in that comfort shows or reveals that they don't have anything to worry about. That's what that comfort is. I don't have anything to worry about. Am I comfortable in this condition? And as a company, acknowledging where all the good stuff comes from. Like I would not be anywhere if I never met Nathan.
Yeah.
And if we didn't become really tight friends through the process, I would be nowhere. If my wife didn't push me to, keep designing speakers and do the things that I love and then translate that into a company, I would still be doing whatever in the pipe trades, like not really enjoying my job.
No.
Like I enjoy this way better. I work more hours and I work harder, but I enjoy it way more because of what the industry has given me and what this experience in this industry has given me. So I think that leads to a cohesive unit that ultimately the end user is actually investing in. And I think that's worth at least a mention in the discussion of, what are people buying when they're investing in audio gear that is of a certain caliber.
Yes.
You walk into Walmart or whatever, store, and you buy something for $50 and you're investing in that store and that store's policy to look after you after that point for whatever that $50 is going to give you, or you buy it on Amazon or whatever. When you're dealing with a manufacturer direct like us, or very close to direct, we only have one layer of certified representatives between us and clients, and even at that, I still handle a lot of clients, head on.
Yeah.
You are investing in what we have to offer, and that does look a little bit different when you're getting into, that personal touch application.
Yeah, I agree, and I wholeheartedly, and I feel like we could almost divide off a number of brands from such as yours, from perhaps the mainstream of the hi-fi industry. I think there would be, the listener might be wondering, I've never heard of this company before. This gentleman seems to know exactly what he's doing. Why have I not heard of them? And, and so what I'm leading up to saying is that there is very much two kinds of, there's a niche within the hi-fi industry, if you want to use that horrible expression, which is brands that are, such as yourself, that are only concerned with performance, reliability, exceptional customer service, and possibly don't possess much of a marketing department. And on the other hand, the brands that everyone knows clearly have a fantastic marketing department. One then wonders about the rest. The marketing department talks a lot about engineering and special features and a lot of acronyms, but you and I both know that is marketing. It's in many cases, not in all cases, but I mean, the reality is your subwoofers, as I understand them, are not inexpensive. They're clearly made to chuckle. They're clearly made to exceptional standards, and we're going to talk about that in a second. But I think that's, and then the problem is for you and for I and other people who are very concerned about quality is that a lot of people actually don't care. So you're sort of selling to a niche of clients in a way. Well, people think they care about performance and quality, but in many cases, they've not really heard anything that serious anyhow, because you can only hear what's in most hi-fi stores, and most hi-fi stores sell what sells, which is affordable, well-marketed products. So yes, you do operate in a slightly in a different dimension to some degree. I mean, do you want to highlight some key, rather than, let's not talk too much about the science and perhaps talk about some of the aspects of the way you make things and some of the troubles and extra effort that you go to that does help to delineate your Harbottle subwoofers from the likes of a Velodyne or a RAL or something that everyone knows in a subwoofer. What do you think are the biggest differences?
Well, it's manufacturing to a standard.
Mm-hmm.
Like, it's a very short jump to get into science. So to honor what you asked, I'm going to stay away from science for the time being.
For a second.
But that standard is based in science. It's based in physics. So everything that you hear an audiophile talk about in terms of like transparency and like, timbre and overhang and thickness and like all these words, they're actually describing a physical component and a physical behavior of the system.
Indeed.
So when you're looking at engineering to a standard, you have to define the standard, right? Like how do you manufacture something and go, okay, well, it's really high performance. Well, what is performance? Like, what is the basis of that metric? If it's SPL 2-meter ground plane or 1-meter ground plane, that needs to be highlighted that the measure of performance is SPL and SPL only. We're not going to infer other meaning. But if it's SPL and distortion, okay, what kind of distortion?
Yeah.
Like most people don't know that there's like many kinds of distortion. Harmonic distortion is like, it's just the mechanical components of the driver.
Yeah.
You want to reduce harmonic distortion? Use better parts.
Yeah.
Job done.
Yes.
Like it's really not that hard to deal with. It is kind of scientific to a certain degree because it does jump into intermodulation effects and a few other things. But it quickly comes back to, okay, what is the performance standard? And so our performance standard hinges on a number of factors. Number one, it hinges on inaudible distortion. So all distortions of all types cannot be audible at the maximum power handling capability over the engineered bandwidth of the driver. Now that's probably a big mouthful, and people are going, "What?
Yeah,
engineered what of the what?"
I think my eyes glazed over myself. It's
and
I mean,
what
you really want to do in an ideal world, the woofer would perfectly represent the waveform that's been recorded of, let's say, a kick drum, tom-tom, whatever. We'll talk drums, for a second. Well, bass guitar or double bass.
I played all kinds of stuff.
Yeah.
You can
just
refer to whatever instrument you want.
You basically, so someone has gone to some trouble to record that instrument, and really in an ideal world, your bass system would just follow that waveform perfectly. Is that what you would regard as perfection?
Exactly.
But
that's impossible.
But that's well, is it impossible?
It's physically impossible. The only thing that can reproduce that exact recording is the instrument that created that sound to begin with in that exact environment. And so when we take a step back to defining the elements of performance, we have to do exactly what you're talking about. Define sound.
Yeah.
What is it that we're listening to? And anytime you start to play back something through a system that is outside of the recording studio, you're going to introduce colorization of the sound. And I just used an audiophile term, I'm sorry. But it will change the sound, it will change the waveform, of course, because it's not exact. Now, how does it change the waveform? Well, the entire system is made up of different components. You got the speaker driver, the box, the amp, and then whatever is processing or shaping the signal going into the amplifier. So it's your input stage signal shaping. Now, all of those things combine to make a certain sound a certain way. Now, the job is, like, if the system is completely free of color.
Yes.
I'm sorry. I'm just making myself cringe. If it's completely free of
It's actually not.
Of other,
it's not a bad word, though, is it? I mean, in the sense,
it really isn't.
I mean, really, color. I mean, I could be completely wrong, but my life has been spent thinking that color in a hi-fi system is a deviation from a linear response. And obviously there could
be.
Yeah,
but it can also be very pleasant.
Yeah, I was just about to say that deviation could actually be a rose-tinted deviation, and is quite enjoyable. And I'm not, to be honest, I'm not really against that. I mean, that's where I stand. That's not relevant to what you're doing there and your where you sit in this.
It is actually,
but I think color is an okay word. Feel free to use color.
Okay, I'll use color. So when the system starts to play back the original recording, it is going to add or even subtract certain elements of that playback. Well, what's included in playback? Well, you have the original signal, right? You have all manners of distortion, bad and good, because there are some distortions that are not offensive and they do sound pleasant, right?
Yeah.
And then you have the opposite of distortion. Like, what is distortion? Distortion is frequencies added that were not supposed to be there to begin with, especially harmonic distortion.
Indeed.
They're added, and they're not supposed to be there. All distortion is added, and it's not supposed to be there. Now, because of Newton, for every action, there's an equal and opposite reaction. And it drops some science. For every action, there's an equal and opposite reaction. So because we know distortion exists, compression also exists, or the lack of the original sound wave. It's compressed. Well, how is it compressed? Well, there's many ways that it can be compressed. And so in our company, we define performance by these things. We've got the original sound, right?
Yeah.
We've got distortion, compression. We have efficiency, which is affected over the bandwidth of the driver. So what is it capable to? How deep, and like what's the bandwidth in frequency? And then the overall output. So how loud can it go? All of those things need to combine in order to create, quote, this kind of sounds bad, but it's the least audibly offensive result as possible. So distortion can't be audible at maximum output. Compression can't be audible past or measurable past 1 dB at maximum output. And everything is referenced to maximum output over the design bandwidth of the system. And I just used two different words. One was engineered bandwidth and one was design bandwidth. Just to give you a hint on what those are, engineered bandwidth is the engineered bandwidth of the driver itself. The design bandwidth is the design bandwidth of the system.
Okay.
Those can be different from each other.
Well, yeah.
According to what the amplifier is capable of handling. And from that standpoint, we found out really quick, in order to maintain a performance metric within that very, very small box, roughly the size of a postage stamp, we have the insane task of monitoring quality control. So our quality control measures are on our baseline models in Cassini. Like our company has a brand name called Cassini, and all of our subwoofers fall under that. And Harbottle Audio is like basically the engineering head, and Cassini is the brand that we produce. We also produce one other brand, and we're working on another one right now. But outside of that, inside Cassini, the baseline models, they are Um, oh my goodness, I just lost my thought. That's like
You were
Alzheimer's.
well,
Ah,
you're getting on a bit. I mean, like
I'm
it's kind
40. Yeah, I'm just about 46. Like,
crikey. Yeah, well,
time's
that's when
up.
it starts. That's. I reckon that's almost exactly when I started not being able to.
Oh, sorry, QC.
Yeah, you're talking about QC, and do talk about QC, and then I want you to just step sideways, because the thing that I've seen of your products that's interested me is your better models would appear to be made from maybe birch ply, but some kind of plywood. And then you've gone and laminated them with carbon fibre. I want to know about that, because other than the fact it
Yes.
looks spectacular, because I just saw a YouTube video of someone that you paid off to do a really good review. But he shot some very nice images of it from different angles, and it looks that's a cool finish. And I guess there's a
Cool.
functional reason. But go back and finish off
There is.
the QC story.
QC. Our baseline models hit just over 500 points of quality control on every single unit produced.
Mm-hmm.
And from there, it goes up to just around 600 on the more complex models that we build.
So what's
And that's
a point of quality control? You mean that's at a stage? There's X number of ticks you put in boxes, or what? What do you mean by the 500 points of quality control?
we physically test every single piece. So, like, let's say in the Cassini line, we've got the tradition models, which are wood finishes. Well, in our wood finishes, we have Baltic birch ply, and then we laminate full thickness raw veneer on top of that.
Okay.
So we don't use processed split veneer. We go full thickness. We actually sit it, and we have our own sewing part in our facility, a sewing section, and we stitch our veneers together, and then we apply them. So they're full thickness, and now when they're done,
Oh, hang on, whoa.
they're actually 14
What's-
ply.
Okay, so when you say full thickness, you mean like I don't know what that is. Is that like 1.2 mil instead of 0.6, or is that 6 mil instead
Yeah.
of 0.6, or?
Yeah, it's like is right around an eighth of an inch. So
Yeah, okay.
it's like
Yep.
like 2.5 mils or so.
Yeah, eighth
Like
is
it's full.
yeah,
Actually,
3.16 or
that's
whatever.
a better question for Nathan, because he's the actual woodworker.
Okay.
But it's full thickness raw. We don't buy it processed. We process it ourselves.
Yeah, okay, interesting.
Now,
All right.
the risk of putting veneer on
Yeah.
is that you can, if you're not careful, you can get air bubbles underneath the veneer, right?
Yep.
Stands to reason. It's just like, putting 3M film on a window or whatever. You can
Yeah.
get air bubbles in it if you're not
course.
careful.
Yep.
And so the idea is that we do a knock test on the sheet after it's veneered to make sure we got full adhesion. And we actually test that piece to make sure it's good. And same with our driver cones.
Okay.
We pop a cone off the mold. We do a quick resonance test to make sure that it is sounding the way it should sound.
Okay.
Um,
And that's a
co-
point of quality control at that point. That
one point
counts
of
as
quality
one, yeah.
control of.
So then
many.
500 is a hell of a lot then. So if okay. And so you just
Everything is checked at every single stage. So if you put your hands on it, it's checked.
okay. And you're saying you're checking cones, and that's because you're making your own cones in house. Is that right?
Yep.
Wow. Okay.
Yep.
So you're making your own drivers in house.
Yes.
Okay. So this is pretty
That's where we
serious.
started.
Yeah. All right. Okay. Wow.
Yeah, we machine. We have a CNC shop. We machine our motors. We use neodymium, and we specialize in long stroke drivers. So we use overhung and underhung motor topologies.
Okay.
And yeah, we build everything in house from as close to raw material as possible. So there's only like 4 components on a speaker driver that we actually have made out
Yeah. Okay.
of house.
Yep.
And we bring them in, but those are all what we call hard and soft parts, so they don't actually have any electrical, magnetic, attachment to it. It's just It's like the
Dust
spring
cap or something.
terminals for the
Yeah.
spring terminals. Actually, we make our own dust caps
You
as well.
make your own dust caps, okay.
Yeah, we press them.
I was going to say you don't machine them out of a solid billet of titanium. So, but the
No,
so the
not yet.
So not yet. Yeah, don't. Yeah. Oh, you just had a thought. Voice coils are something are you bringing in, or you making?
We have them made onshore.
Okay.
We have them made in the U.S.
Wow. Okay.
and they actually have to hit really high quality control standards too. So nothing is allowed to leave. Like when we're done QC,
Yeah.
the product is what we call verified for full rated use. So that's the design bandwidth of the unit. So like Cassini subwoofers, they're 5 hertz to 200 hertz. So we run them 5 hertz to 200 hertz full power.
Yeah.
And we do that for hours.
So band
usually
limited
a couple
pink
of
noise.
Days.
Yeah. But, pink noise?
No.
Or just
we
sweeps?
We sweep, we do pink noise, and then we run content. Because pink noise sucks to listen to, so we actually have our own. It does. It's horrible.
I think it's better than
so it's like, well, we're working
sweep.
anyway. We might as well enjoy these things. So we
that's
put
right.
content to them.
Okay.
And then we run them right up to full power, and we just hold them there for a couple or 3 days.
Oh, really? So for 3 days? Okay, so...
Oh, yeah.
That's...
Well, they're designed not to break. If you're going to invest in something that has 500, like a box, like let's be real here, a subwoofer is a box, like it's a speaker box. It's, it's nothing, outside of this world that people have seen. Like it's pretty normal stuff.
Yes, yeah.
But you're going to invest in something that's got 500 points of quality control on it. You want to know that you can run it to the ragged edge and hold it there. And that's exactly where our gear is designed to live. Right at the ragged edge, and it loves it. Like it's just happy. Temperatures are good. Like nothing is getting too hot. Perfect climate control inside the motor, like temperature controls. Perfect like inductance linearity, flux modulation linear. Oh, sorry. I don't want to get too heavy into the technical
into the
stuff.
science.
But perfect linearity in all the electrical magnetic components. And it's just like right in that sweet spot, like a race car. A race car isn't designed really to cruise at 20 miles an hour.
No.
But when you put it through the corners at, just this side of the tires peeling off, then it's really happy. The engine's happy, suspension's happy, everything's happy. The difference is with our gear, the quieter you play it, the more it sounds like it should sound. Like it sounds exactly the same, rather. It sounds exactly the same at full power as it does at very low power.
Well, that's where a race car analogy is appropriate.
Rubbish.
Yeah. Well, no, in a way it's appropriate because you take a road car to the racetrack and it kind of just heels over and falls apart and the brakes go off and the thing ultimately overheats and then it's kind of like worn out at the end of a decent session. Whereas a race car is made from better materials, designed to operate, at higher temperatures, at the limit, and last the appropriate amount of time. And everything's engineered properly to work at the limit of that vehicle and not overheat and fail. At least that's a modern race car. Obviously an old Lotus, bits just fell off and maybe it finished the race or not. But
lots of trouble, usually serious.
Usually serious, always serious. They should change the name. Lotus. They're a very pretty car, though. I've still never owned one. I really wanted one, but I guess I'm not going to get one. They've kind of gone up during COVID as well in a way that stops lots of people from. Well, all cars have gone up, and I guess the same has happened in Canada. But let's not move on to the subject of cars just yet. I think that's a great analogy. I mean, there are the fact that your subwoofer is the race car of the subwoofer world versus XYZ brand that sells for a lot less money that literally when you pound on it will fold. It will compress is probably the thing that I guess
Compress.
it'll compress vigorously, and it will partly do that, I guess, because protection circuit will kind of soft limiting, if you like, will cut in and stop
Well,
you from
yeah,
destroying it.
compression can come from anywhere. That's the interesting thing about DSP is that you can program, like in our DSP systems, we can program bandwidth compression. And we can take a bandwidth, okay, between these frequencies at this power, I want this much compression. And so you can limit a system in such a way so that it's preserving excellent sound quality.
Yeah.
But you're not getting linear output performance
No.
across the board, across the amplitude, across that bandwidth.
Yeah.
So in dynamics, you start losing, especially in a subwoofer, you start losing the lower frequencies. And that's an interesting thing about efficiency, is that efficiency it affects so many different aspects. Like if I ask people, like when clients contact me, they'll ask me like, well, what is this efficiency thing about? And I say, okay, well, what is inefficiency? Well, if you have SPL, say you've got 10 decibels, and then you turn your receiver up 3 decibels, and it's putting out 13, and then you turn it up 3 more decibels, you're expecting 16, but you're only getting 14, you've lost 2 dB. That is inefficiency. But it's inefficiency in dynamics.
Yeah.
And that's what a lot of people start missing when they're looking at compression. Where is that inefficiency introduced? Is it in the driver? Or is it in the amplifier? Either way, you're getting a nonlinear dynamic range across the bandwidth. So if your bandwidth is, well, I start at 5 hertz, so we'll use 5 hertz.
Okay.
And we go to 5 hertz to 120 hertz. If your bandwidth is 5 hertz to 120 hertz, and you're not getting linear output in dynamic playback, let's say between 5 and 20 hertz on brand ABC subwoofer at X amplitude, or how much power output you're expecting, then you're getting a non-linear playback and compression is being introduced. But where is it? Is it in the amplifier or is it in the driver? And that's the big question that I found in my years of R&D before I even started my company. I found that it was very difficult to nail that down from one brand to another. It's not necessarily a regulated metric that is used. They go, okay, well, it's maximum SPL and this is the bandwidth and here's the power, like here's the amplifier power. Kind of like the highlight reel, which is great and fine. I mean, I use the highlight reel myself, but I also engineer and build to a standard that doesn't allow me to deviate. So when somebody puts it in their room, they can accurately predict, especially like a room designer, like a professional integrator, they can accurately predict what that subwoofer is going to do in that room, and they can accurately account for headroom. So how much dynamic headroom do you actually want? 3 dB, 6, 10? You know, like what exactly do you want out of the system? And then you can size the system appropriately. So from a tool standpoint, engineering to a standard, hitting quality control that assures that standard every single time on every single unit. Like, let's put this in perspective. Most people buy 2 to 4 subwoofers. 4 subwoofers for a home theater, 2 subwoofers for a smaller home theater. 2 subwoofers, that's 1,000. That's over 1,000 points of quality control. 4 subwoofers, that's 2,000 points of quality control. Minimum.
Well, it is.
On that system.
Yeah,
it is designed to work. That's its purpose.
What would you... So it works, and we know exactly how it's going to work. So the integrator can calculate, like you say, the amount of headroom over, I don't know, reference level or whatever, and so that they know what the rest of the system has to be to keep up with it, or vice versa. The subwoofer system can keep up with the main system. But I'm interested for you to describe in kind of hi-fi terms like colour and others that you don't much like, where your subwoofer system delivers and in what way is it different to, and I mean, I think, I think RAL, we don't want to talk about brands so much, but these are at different price points completely. So I think we can. Mm-hmm. I mean, clearly your product is superior because it's better built, but it also costs X amount times more, which will come to price in a bit for those wondering. They are less than $1 million, folks, so don't panic. They're not stratospheric. What are people going to hear? They've currently got 2 RALs. Let's
excellent.
say.
I get asked that all the time.
What
generally happens? I have a client that recently went from a product that is really well known, especially in Canada and the US. Mm-hmm. I'm not going to name names. Well, I mean, the price point is so different. The engineering is different. It
starts with P.
Compare it. It starts with J.
It starts with J. Okay.
And he said, and we're talking 2 18s.
Okay. So
he's got 2 18-inch subwoofers, and then he gets 2 of my 18s.
Okay.
C18s. So they're the carbon fiber. Yep. Aspect that we're going to talk about a little later. And he said that there is no comparison. But the first thing that he mentioned was that my product doesn't sound thick. And that's interesting. The first thing that most people talk about is either going to be thickness or how good their main speakers sound.
Okay.
And the second thing that I mentioned is really interesting because I am like a full-on audiophile. I'm a hi-fi guy.
Hang on a minute.
I listen to music.
You're a full-on audiophile on not an audiophile.
Yeah, but I'm a techie. I'm a science audiophile. Okay. Like I don't like really using the words, but I like I like kind of that esoteric stuff. Like I'm a nerd. I geek out on the science aspect.
You heard it here
when
first.
It comes to the audiophile experience.
Cody's a nerd. Jeff from Hey Now Hi-Fi sells really good hi-fi that you can't get everywhere, both online and in store. You may be interested or you may not. If so, check out his website. That's heynowhifi.com.au. That's heynowhifi.com.au. We're back with Cody. Cody Hebert from Harbottle Subwoofer Engineering Laboratories, and you were just explaining that you are an audiophile and a nerd. So continue.
I am, because if you go to my frequently asked questions FAQ on my website, there's a tab that says audiophile terms or audiophile terms explained in terms of physics or something like that. And I physically sat down. I took every single audiophile term that I could think of that I've been using over years.
Yes.
And I applied physics to every single term because it can be explained in physics. And there's nothing really wrong with that inherently, as long as there's a baseline for science that attaches itself to the more colorful explanation or the colorful word in that aspect. Like I like the geeky, nerdy stuff. Like I run fully active stereo 2-channel. Mm-hmm. My amplifier that I built is somewhere around the $20,000 mark for me to build it.
Whoa, really? Okay.
I've got.
Is that?
Yeah, and I've got 2-channel bookshelf speakers that are fully active.
Okay.
Who runs bookshelf speakers that are fully active? But I live in a smaller house and I don't really listen that loud. I listen loud in our workshop, because that's where we build our stuff.
All those subwoofers on test going at 146 dB.
For a change of pace and for my own listening, I have a pair of my carbon fiber bookshelf speakers, and I just sit back and enjoy anything from Foo Fighters to Miles Davis, Aretha Franklin, Etta James, like, Sam Henshaw, Anthony Hamilton, like the works.
The work, yeah.
That's my taste. And when it comes to explaining, physics, attaching that physical action or the physical characteristic of a speaker to, a word that has meaning, or a word that, kind of describes something, now it takes on a different kind of meaning. So yeah, I am a bit of an audiophile.
So you're an audiophile, which is, an enthusiast for equipment.
Enthusiast, that's a better
that
word.
Reproduces music. The difference between the brand that starts with J, 218s, and two of your C18s, you talked about thickness. So that's in that comparison. Yeah. So what the client is going to hear is to continue that comparison when they change subwoofer.
So thickness is compression.
Okay.
Thickness specifically is driver compression. So what happens in compression itself, when it's at its full realization, where you're compressing into an audible spectrum past 1 or 2 dB, and it's clearly audible that you're losing decibels. Okay, well, what people will think of first is, I'm losing output. And that's true. But it's also an expression of inefficiency. So where is that compression coming from? Well, there's lots of places where it can come from. Like, the most popular is thermal. Mm-hmm. So how hot is the voice coil getting? Well, that thermal can affect the magnetic flux characteristic of the driver. And so it can't articulate and get out of its own way. So the driver starts to lose the ability to move. And that's why you stop gaining SPLs, because the driver just simply can't move. And the more power you put to it, the hotter it gets. The hotter it gets, the more it can't move. So it's really like a complete lose-lose situation when it comes to thermal compression. But then you also have suspension compression. Yeah. So a lot of PA gear is designed to save itself. Like, most pro audio equipment is designed so you can turn it up and just shovel as much power as you want to it, and it will limit on the suspension, and it won't be able to go anywhere. Yeah, because the suspension is too tight. Yeah. However, the coil and everything is totally fine, and it can handle all the thermal aspects. Yeah, it's just the suspension isn't going to let it move. Yep. Once it gets to a certain, a certain output level. And when that happens, when you start backing off the power on that kind of driver, what happens is you get what I like to call early compression, and that leads to intermodulation distortion, or intermodulation, specifically intermodulation compression. It's where the physical components in the suspension and the cone start to interact with each other, and they either add distortions that modulate with the original sound wave, the frequencies coming into the driver. It starts to modulate and change things, or it will compress certain frequencies, because, again, Newton's third law, we end up seeing some compression in specific frequencies that modulates and changes. And so what happens is the sonic signature sounds like a cartoon version of itself. It is like, it's like, oh yeah, that sounds like what I think a Lamborghini Aventador should sound like. But it's not, but the guys that own it is not quite right. It's like, yeah, it's there, but it's not quite what it's like in real life. And because that effect gets worse as you start to compress. So from just those two aspects, we can see you get thickness, but then you get the loss of detail that lends itself to reality. And those two things are the first things that show up when people ask me, what is the difference going to be? And what the feedback that I get is that it's those two things. And generally, the second one, where it's like a cartoon version of itself, when that's removed, or the thickness is removed, the people who are really into their main speakers, like they're like, they're super stoked, say they got Salon 2s or, some upper end focals or whatever.
Yeah.
And they're like all about their main speakers or their LCR in their theater. They'll come back and say, my main speakers sound better.
Yes.
What did you do?
Yes.
It's like, well, what happens in the low end of that subwoofer affects the top end of the subwoofer, which affects the crossover of the subwoofer to the main speaker, which affects the load on that main speaker. So now your main speaker is now unburdened and can move more freely, and it will sound better. You'll get more of the sonic signature out of your loudspeaker than you would have before because you're removing the stress off of it. And that's nuance. Like that's really tough to place because
when you say
most people hear differently.
Yeah.
Like they prioritize different sounds differently. And so the thing that stands out to them first will shift a little bit, but those are the basic rules that tend to hit first.
Okay. And so thank you for that. So basically it's tighter, cleaner, less, there's no added color and obviously it hits harder, much more,
Quick
because it's quicker, and there's this detail in the notes that's blurred by this compressive thing that's happening with the lesser subwoofer. But you said that you're taking the load off the main. You're not really meaning you take the load off the main speakers. It's just that it's a cleaner crossover region because presumably the main speakers are driven, separate crossover arrangements and power amps, right? I presume that if it's an AV system, the controller, the preamp processor is dealing with the crossover, and there's separate power amps. So can you just clarify that point? And then what I want you to explain is you've achieved this, but what are the top 5 things that you've done in your subwoofer that make it different? And I guess we're talking materials and structure and design. But yeah, just before you tell us that though, so when you say it takes the load off the main speakers, do you want to clarify that just for...
Sure. So what happens in a crossover point is you end up with, especially in a room with a subwoofer, you end up with something called phase shift, right? So phase is basically time in terms of 360 degrees.
Mm-hmm.
And when you have phase shift, but then you try to combat it with gain, like boosting and that, what you're doing is you're putting a Band-Aid on,
trying to fill a hole.
You're trying to fill a hole that really isn't there. Like, the best tool is something else.
Yes.
And so that would be integration in the time domain.
Okay. Yep.
Now, when integration in the time domain is done and phase shift is looked after and all those things combine so that crossover region of the main speaker can now sum really well, when you're not producing compression and upper bass distortions and inappropriate behavior of the subwoofer, the lower bass of the speaker, the tendency to drive the loudspeaker, the main, harder to get the sound you want out of it because the subwoofer will only ever do so much. So you kind of like run it. A lot of people will run it up to its maximum. Okay, the subwoofer is doing everything that it can. The tendency to push the loudspeaker to match is now way down because you have dynamic capability in the subwoofer.
Yep.
So what this can allow you to do is a number of things. One, you can play with time domains. So like our DSP systems are very powerful. You can play with all pass filters, delay. You can even invert phase. You can do all kinds of stuff with them. And then you can actually run our subwoofers because, like, keep in mind, Cassini is good up to 200 hertz. So if you've got something like, say, like a Magnapan or, a big electrostat, and it's having a hard time getting down to, let's say, 80 hertz,
Yes.
you can drive it up to 130
Yeah.
and cross the subwoofer off at 130.
Yeah.
Or cross the subwoofer over, at 130 or slightly below, and then deal with the time factor to get it to image properly to the center between your left and right. And then what you've done effectively is you've actually moved the crossover point, so the main speakers don't have to produce as much bass in that one option.
Yes.
And so you literally remove the strain by telling it doesn't have to push so hard.
Yeah, and
or
continue.
Just working in the time domain, you don't have to drive gain so much. You don't have to push the main speaker so much in order to get the desired output or the effect that you're looking for and then in turn compromising the main speaker's own ability to produce stroke, which is, the driver moving back and forth. So that starts to lead to a better fidelity experience. Even though it's nuanced, it does actually work because everything is pointed towards efficiency. Like, how efficient can this system be when we start to remove inefficiency, i.e. compression, out of its behavior? And especially in the upper bass regions, you really have to do a lot of DSP work behind the scenes, like in a factory preset. You got to do a lot of DSP work in order to make sure that the driver doesn't limit. And it becomes challenging. So if you're going to start limiting using the amplifier to limit out the driver, or use the DSP to limit the driver behavior so it doesn't produce poor fidelity effects, well, then you have to make the decision, where is that audible limit? Like, how far can this subwoofer go before it starts to produce something that can affect another speaker? And that becomes a real challenge when the design bandwidth of the driver or of the subwoofer is, 110 hertz or 100 hertz. That becomes a challenge because we don't know what the main speaker is going to do in the room. And I remember a podcast that you did a little while ago about room tuning and integration. And the one guy, the fellow you were interviewing, he said that the client was shocked and awed.
Yes.
Called him and he said, "I thought you were just joking about about the room mattering this much." He's like, "I moved it 10 millimeters or something. It was a small amount, just a couple of tweaks."
Amount. Yeah, it was more than 10, but it was a tiny amount. That's right, yeah.
Yeah, but he fought it because he thought, well, this individual, he may or may not know, but then he finally broke down just before I think he was going to sell them.
That's correct, yeah.
Or something. And so he's willing to give up everything that he put in. And then he stopped himself, made a correction, and bang, it worked. Well, that's the room effect, right?
Yeah.
And that's where a subwoofer that gets out of its own way in an enclosure that just shuts up, a nice, quiet, inert enclosure, a subwoofer that gets out of its own way and lets the loudspeakers do their job, it makes everything sound better because it's not introducing stuff. Can you repeat that?
That was actually my computer talking because, in fact, it was the guy reviewing your subwoofer. I just opened the computer because I just wanted to see what episode that was, because you're referring to David Spargo,
right?
His
David
episode,
Spargo, yeah.
And David Spargo, actually, I noticed on your website that you've got a link to a YouTube video, which we've not linked to, where the interviewer, and I know the gentleman's voice, who works at the ABC, I can't remember what his name is, but he interviews Neville Teal, and David Spargo knew Neville Teal well, so that was it's a small world, so there's just that connection there. But I was going to just to clarify a couple of points. Absolutely, I guess. I mean, well, you're saying that your subwoofer is of such quality that placement is still obviously important, but
Big time.
but you're not having to make as much. You don't have as many issues to deal with because it simply produces a cleaner sound. So you're talking about the cabinet there for a second. I still haven't decided what episode that was. I think it was 14 off the top of my head. And I want to say, because for those listening, because we do have a bit of a back catalogue of stuff and some very interesting people. And I'm checking it right now. I've opened the page of our own website, and there it is. It's not episode 14. It's episode. It is episode 14. Yeah, episode 14. David is a bit of an acoustics. What's the word? I hesitate to use the word genius, but he has a very good understanding of it, and
he's good.
Ably assisted by knowing Neville Teal, doesn't Neville have unfortunately just a wonderful way of explaining complex thoughts in an incredibly simple way. Moving along.
Definitely.
What the hell have you done with your boxes, your drivers, and your amplifiers? You've got 100 words only on each subject to explain the key difference. Because it's obvious in a way for me, and I think for many listeners, that clearly a lower priced, more affordable subwoofer, the enclosure is built from some pretty rudimentary, simple materials in a fashion that's sturdy enough not to obviously rattle or fall apart. But other than that, probably
like
compressors.
Audibly rattling and buzzing.
Exactly. They've minimised that. But I'm interested in your decision to use birch ply versus, I guess, everyone's popular choice of MDF, and then in turn you've done this thing with the carbon fibre. And my question is, have you done that on the inside as well? So let's talk enclosures. Why did you involve carbon fibre and birch ply?
My background in structural engineering. The simple answer is that MDF has a higher modulus of elasticity. It's more elastic. It has higher flexural modulus, so it flexes more. And as a product that when you're trying to mate pieces together that run perpendicular to each other, you're creating a bracing structure inside the enclosure. Now, this is loudspeakers as well. What happens is the speaker driver is creating energy. It's the brace's job to control the energy. It's the enclosure's job to fight back against that energy. And so the enclosure, like the tub, the panels on the outside, they will vibrate a tiny little bit. Like you can put your hand on the side of it and you can feel a little bit of the vibration coming through. But the bulk of the work in killing the energy and keeping the energy inside the enclosure and not letting it transfer to the outside environment through the wood is done by the bracing.
Okay.
So, number one, people that say that bracing doesn't matter, I laugh at them unbelievably, because from a structural physics standpoint, if you look at what a subwoofer is doing, it's a little mini earthquake, especially if you're hitting infrasonics. You're trying to produce little tiny mini earthquakes and control them in your room. That enclosure is doing a lot of work. So MDF just doesn't fit the bill when it comes to that. Yes, it damps really well. It's a great damping material. However, there is too much rate of change in the character of the frequencies between infrasonic and 100 to 150 hertz in that audible range. There's too much rate of change for MDF to deal with it. It just doesn't work well as a structurally robust material. So we went with Baltic birch. And from an engineering standpoint, it's really good to engineer with because the behavior is very predictable. And with MDF, you can get some very strange um, resonating patterns that show up. And now with the drivers that we have, because they are exceedingly clean right up to full stroke, so X Max and beyond, is really close to mechanical limits of the driver. Because they're so clean, if the box makes a sound, that sound will go through the thinnest part of the speaker, which is the cone. So it'll sound like the cone is making a sound.
It's a funny thing,
and that's
isn't it?
just distasteful when you're looking at something that is, crafted, by high-tech artisans like ourselves. Like that's, you invest X amount of money into it, and you like having a odd harmonic peek through every once in a while.
Yep.
That's just, that's a corner cut that I personally can't live with.
The whole cone thing is hilarious in a way, because you go to all of this trouble with this enclosure. Incredibly, I don't know how thick your Baltic birch is, but you'll tell us.
3/4, 18 millimeters.
Okay, so so it's as thick as it needs to be. Obviously heavily braced, but is that I mean, it's 18 millimeters thick. It's cross laminated. It's a hell of it's an incredibly good material, and I've got a greater respect for it than absolutely. I've kind of
13 ply.
Yeah, it's good stuff, and in many ways far superior to MDF for a loudspeaker enclosure of any kind. But we are not going to have that conversation right now. But the point is, you've got all of this stuff happening inside the enclosure, but ultimately, you've got a 12, 15, 18-inch diameter. Well, the cone's not that diameter, but you know what I mean. The frame is that size. The cone is a bit smaller. But the point is, you've got this cone. It's a millimetre thick or something, 2 millimetres thick. The rest of the box is 18 millimetres thick, and in your case has a carbon fibre cloak over that. But the sound can just go straight out through the front, through the cone. So I know, right? It's one of those weird quandaries with speakers. It is very irritating, and there's kind of no way around it. So I want you to explain about the carbon fibre, but then talk about your cones and how you feel that you might have reduced, like you said, letting various problematic sounds get back out through the cone. But so, where does the carbon work with the Baltic birch? Explain that to us, please.
Okay. So what we do is we build what we call a carbon enclosure. So let's call it an 18. Those are tagged C18. So we build a C18 out of Baltic. We shape it into its final shape. And then we cover it. We cut a print and we cover it with carbon fiber, and then we infuse the carbon fiber, and we make the entire box into a composite in structure. So that composite structure is now the entire box. It's not made from composite material.
No.
A lot of people would think it's like, oh, they put carbon fiber on the ply and then they cut it up and they glue it all together. Not even close. We turn the entire thing. So what happens is the carbon fiber clamps down on the Baltic underneath it, and it's like grabbing onto your wrist and then never letting go. It just squeezes it from the outside, and it holds that tension. That's its job, is to hold the tension forever. And what that does is a couple of things. It kills resonance. Yes, it damps from the outside. So it kills resonance, et cetera, but it also braces and adds stiffness to the enclosure. So the 18 millimeters is now closer to 23 millimeters thick of its effective thickness. We've gained thickness even though it's one layer thick of carbon fiber on there. We've gained effective strength to the enclosure as a whole. And when you couple that with the appropriate amount of damping, what you end up with is an extremely inert box. And when you have an inert box and you've got a lot of very clean stroke, you now have free reign over another level of fidelity. So the box is clean, the stroke of the driver is clean, the amp is clean right up to maximum, inaudible amp um, uh, contributions other than beautiful crisp signal, high power signal to the driver. Everything is crystal, and you have free reign over another level of fidelity. So that fidelity gives you more freedom to do other things. Like you can push the system harder.
Yeah. Well, yes.
Well, I mean, it's already designed to go right to maximum, but you can push it harder in your own space. And an interesting component that I didn't really count on. I mean, I experienced it myself when I was first, doing R&D on my own designs. But the room character got better. So like room distortions started to change.
Okay.
Go from one subwoofer to another, but the room characterization was oddly different in a very good way. It's almost like distortion component, like harmonic, especially like mechanical distortions, when they're reduced to a point where they're not allowed to even show up anymore, it's like they kind of reduce the harmonic effects in the room as well, and they get the room to settle down a little bit.
Okay.
And that might be like a placebo thing. That might be just my own experience. I have had a couple of clients say the same thing to me as well. Like they've experienced it. So it's probably like, a little bit, one-off or, rare, like hen's teeth. But, like when you get that extra level of fidelity with all the performance that it comes with, like for some people, they're looking for that end game in fidelity. Like they want it because of an inherent dissatisfaction. Like I see a lot of upgrade-itis in the industry. A lot of my clients come to me because they've had like literally 5 different subwoofer brands, and either they failed or they don't sound right. They sounded great when they first started, but the sound degraded over a few years' time, and they're just kind of tired of it, and they just want to be done with it, like one and better. Done.
Yes.
Cry once or pay once, cry once, or whatever. They kind of adopt that approach, and they just roll with it. And so the Carbon series fits.
The quality remains
what they're looking for
long after the price is forgotten. The
exactly
well, depends how bad the price is, I guess. You mentioned amplifier, Class D, Class AB. What sort of amplification do you?
Class D.
Class D. Yep.
We're pretty open about who we use for our amplification. We use Pascal. We've been using them since pretty much day one.
Yep.
We did some tests with quite a few other amplifier manufacturers. But when I started rolling out, I started with Pascal, and I think I'm going to end with them. They've been excellent as an OEM for, so many years, and rates of failure are really low.
Yep, good.
And their topology really fits what our drivers can do. And that's one thing that can't be overlooked, is the topology needs to fit what the driver's capacity is. And that symbiotic relationship has to exist. Like,
of course,
they got to work together.
Yeah, no, absolutely. The cone material, how thick is it, and is it carbon fiber? If it's on a Carbon series woofer, it is carbon fiber. And you say you're making that yourself?
All of our cones are all carbon fiber, multi-layer thickness. 21s and 24s are like 4 layers thick. And the 18s down through the 12s are 3 layers.
It's a pretty hefty cone then. So
they take about, in our crush tests, we were doing deflection tests, and then we decided to move it to a crush test to see what it would actually do.
Yeah.
Deflection started, I think, at 600 foot-pounds.
Okay.
square inch, and then then it actually broke at like 1300.
Wow, I bet you
pounds.
that went off with a bang.
Yeah, yeah, it snapped hard. Yeah, no, they're really robust, but they, again, carbon fiber isn't just about stiffness. It has really good characteristics when it comes to deflection, when it comes to damping, especially in damping. Like, you don't want the cone to be so rigid that it creates harmonics within itself, because then again you're adding to the original signal, which you don't really want to do if you're looking for fidelity. And so the character of the cone does really matter, and its strength and stiffness and damping characteristics matter. So
Oh, yeah.
carbon
Well,
fiber for
yeah.
us is the best fit.
I mean, ultimately, the cone is the thing that is producing the sound, after all. So, yeah.
You betcha.
Surrounds, no exotic materials there. You're
Treated foam.
yeah. So a
Yeah.
heavy duty foam. Yeah.
Yeah. They have to have the right amount of compliance,
Indeed.
so so the driver can articulate. So we focus on what the surround can do at full extension. So when you're producing, let's say, 10 hertz, and the cone is traveling to X max, it also has to produce like 100 hertz frequencies in order to fill out the detail within
Yes.
that full
Yes.
X max stroke. So it has to be able to articulate at really very fine detail at very high extension for the low frequencies. So it's got to be able to do it all. So our surround selection and our spider selection is very, very particular when it comes to its behavior across the stroke level, and how much content is being created within, again, the design bandwidth of the unit. So for the carbon subwoofers, that's 5 to 125 hertz, and for the Cassini tradition subwoofers, that's 5 to 200 hertz. So it's got to be able to produce all of that very, very cleanly and with like very good authority.
Indeed. And what when you say X max, what is the linear travel? And of course, it would be linear because of this state of the art design. What about an inch or something? What's the linear travel of a CA18 off the top of your head?
The carbon 18, that is underhung, so linear is 36 millimeters.
Oh wow! Okay,
that's X max. Mechanical is 40. And we drive them routinely to about 38.
Okay.
38 to 39.
So
there's
really,
a couple of
right
models
there.
that I can get up to like 39 and a half,
Okay.
and they maintain perfect thermal linearity as well as inductance linearity, inductance linearity, thermal, all the linearities, flux linearity, all of that stuff, like magnetic force. All of that stuff is really nice and clean. There's a couple of models that can get that high, like 39 and a half millimeters or so, like right at the edge of mechanical hard bottom. So, and that's one way. So, two way, it's maximum stroke capacity is around 3 inches on the carbon. On the Cassini tradition line, that is 25 millimeters one way, so 50 millimeters two way. And we can it's an overhung motor, so they are a little bit stroke limited, but we can scoot past it a little bit by, a few millimeters here and there,
Okay.
depending on the load that's being put on it by the content. So that's where a nice robust amp really helps out. It allows things to float nice.
I want to get your thoughts on a couple of things in the subwoofer world that I find amusing and slightly concerning, and I just wonder whether I want to get your take. Ascendo, if that's how you pronounce their name, makes some enormous woofer. Like the cone is, I forget the diameter.
50 and 80.
Oh, yeah, I think there's like an 80. Yeah. So, what's your thoughts on an 80-inch subwoofer? Is that a is that I mean, clearly it doesn't have to move as far to move a certain amount of air, but I would have thought there was a sweet spot in diameter. What do you think that is?
My first concern on really large diameter drivers is the nonlinearity of air.
Mm.
When you get to a certain point, the air itself becomes nonlinear when you're using a cone to move it. And when you're producing multiple frequencies, both in the audible range and in the infrasonic range, how do you control that nonlinearity? And that becomes concerning because there's a certain amount of decibels per liter that you can extract.
Mm-hmm.
So when you're dealing with this massive cone area, the weight of the cone itself would require so much stiffness of the suspension that the power applied would have to be out of this world in order to get it to articulate properly. But then you're looking at overcoming so many physical challenges just in the realm of physics, like, cone sag and
I mean, we could categorize it as a marketing exercise, surely, I would have thought. I mean, I don't know. I mean, that's the way it strikes me.
Yeah, I mean,
and it's a great marketing exercise,
sure,
really.
But I haven't heard anybody say it sounds terrible either.
I've heard it at a distance at a hi-fi show. It sounded pretty terrible at a distance through about 18
really?
walls. Because it was, it was going through the whole building.
Well, there we go.
Look, but you're right. But you're right. At that show, no one said that it sounded bad. It was lots of people mentioned it. People were annoyed that it was, of course, was leaking into the whole hotel, But I mean,
everywhere.
I think I was a floor or two floors higher or something, and it was But no, that's a decent comment. Yeah, no one said, oh, and it sounded terrible. That's not what they've said. No, so but I mean, it is a great marketing exercise because
Well, it's like my Carbon series. Like, how many people are looking for that level of fidelity? There's a few. I do sell them. I mean, I've got theaters that just have Carbon subwoofers, like 424s, C24s, and all that. But ultimately, where the Carbon subwoofer came from was my desire to figure out how far can I go in engineering. A, the enclosure, B, the driver, C, the application of the amplifier via the DSP to make the ultimate. And so it's kind of like I don't really care about anything the industry is doing statement. And honestly, I mean, I'm pretty clear about that on my website. I really don't care about, the industry direction or anything like that. I'm here to build the best thing that I can possibly build. And it started with the Carbon subwoofers. So, I mean, as an engineering exercise, I think they all have merit. But like I said before, the only thing that I worry about with large diameters, that's one of the big reasons why I haven't built one, is the nonlinearity of air. Yeah, you could probably produce 100 millimeters of stroke with a massive, gigantic cone and everything else, and that would be fantastic. But at a certain point, the fidelity aspect of it only makes it usable to a tenth of that.
Yeah.
So, why go to that extreme when the practical application? I guess I called myself before hopelessly pragmatic. I always think about the practical use. Can this thing be used? Even though the Carbon series is a really extreme subwoofer, yeah. It's also, can I use it? Is it too big? Is it too much of one aspect of audio versus another? And I tend to lead my entire business that way. I don't get myself stuck in decision paralysis. I'm pretty good about that, but it's still, I force myself to ask myself those questions and then answer them with a very real answer. No, this is silly. And that's one of the reasons I don't I don't offer a ported subwoofer. That's one of the first questions I get asked. Why don't you do ported? It's like, because a ported subwoofer is like 3 times the size, and I can do just as well with the same amount of money in a sealed, and you don't have, like port phase issues. You don't have any port noise issues. I mean, if you really want the wind, we can do that.
If you really want the wind.
I can.
Yeah.
Well, some people like the wind, the tactile, from the wind of the
As
sub,
in the trouser flapping bass. It's
exactly.
Yeah,
exactly. So there's that pragmatism that follows, my design inquiries, and from like an engineering exercise, big diameters, they can be, and they can be awesome, but where is a practical application when, the rubber hits the road? Like, where is that point?
Well, there's no practical application unless you've got some enormous space, and then really it's just.
Yeah.
I feel like it's something you clearly just rip off a panel off the wall somewhere and go, look at this giant subwoofer I've got. I mean, to your friends. There's I typed in high-end, high-performance subwoofers into the internet, and I got all sorts of things from really not that expensive to $5,000 or something. I then went to Reddit, which is where all good information is obtained, and there's some interesting.
Was that sarcastic?
Oh yeah, yeah, absolutely. There's two lines of thought at Reddit. There's the one where $4,000 subwoofers is better than anything you're ever going to get out of one subwoofer of any kind. I would have thought that was crap times 4 more than anything else. But anyhow, but then there's the other thought that there's that Macintosh apparently have got some. So a few name brands have thrown their hat into the ring for a Mac. Have got I think a $65,000, and I guess that's US dollars.
Yeah.
Got any thoughts on that? We're not sponsored by Macintosh. You can say whatever you want. I mean, I'm sure it's A, got a blue light in it, and B, a large badge. But do you know anything about that?
Meters, man.
Yeah, blue. Yeah. I mean, it probably does have a VU meter on. Who knows? But I don't really care. I didn't really think Macintosh were much of a speaker maker, but I guess it's the point I'm attempting to make poorly is that high-end, high-performance so often is equated to price and price only, and there's really two kinds of products. There's those very effective, affordable products that maybe you do use 4 of them to distribute room modes or deal with room modes to some, not so much distribute them. You're not going to distribute them. You're going to distribute the modes from each woofer, even amount, balance them off, whatever. And then the other way is you have one serious, enormous $65,000 subwoofer. Now, your woofers are not $65,000, I believe. I have no idea how much they are. I think I did see a price some years ago. I don't think you've got pricing on the website anymore. What is a CA18 normally selling for in Canada or the US? Ballpark, no exact pricing, because obviously the spec varies to some degree, I guess. Or you sell them in various ways depending whether they're installed by an installer, which I guess is critical to some degree. And then you offer some support as well with tuning over the phone, so to speak. Just pin an approximate price, though, on it, Cody, just so listeners know that it is relatively affordable.
The Carbon series starts at 15,000 Canadian and goes up from there depending on how it's configured.
Yeah.
And that size range goes from 12-inch all the way up to 24.
Are you a vinyl lover looking for your next great find? Wax Lyrical is the record club for music enthusiasts, delivering hand-picked albums every month. We don't just send records, we give you the full experience, complete with exclusive listening notes and a community of like-minded music fans. Whether it's a hidden gem or a classic masterpiece, you'll discover something new to love. Join Wax Lyrical today and keep the music spinning. hit Wax. That's with a double X, lyrical.com for more information.
Okay, well, I think like I mentioned earlier, we've covered a hell of a lot of ground, and I think we've touched on every sort of aspect of the business and the product. So Cody, thank you so much for taking your time to give us some insight into your dreams and imagination of wanting to build quite possibly the best, lowest compromise, no compromise subwoofer on the planet. So thank you for that. The product again is Harbottle, and I urge you listeners to visit the website. And there's lots of reading on there, and there is that as I mentioned earlier, that great link to the Neville Teal video. Also has a couple of other Australian loudspeaker designers in that video. It's a video I've not seen before, so I don't know how you found that, but good on you. And I can tell you right now, it's the best video out there with Neville in it. There's others, but there's only short ones, and it's an AES one, and it's AES hosted, or at least that's who put it up. Anyhow, AES Australia, I think. Thanks again. I'll let you get back to your freezing. Well, thank you. I really appreciate the time, and I'm sure listeners do as well. And
I just hope I wasn't too boring, man.
Well, it's
Canadians.
I don't think Canadians are boring. What is that? What you're saying?
Well, we're kind of. I don't know. I kind of feel a little dorky about stuff sometimes.
Oh, well, look, it's unavoidable. You're an engineering type, it's
there we go. Engineer nerd.
It is part of the package, unfortunately. I mean, you can't be as smart as you are and be a comedian perhaps at the same time, and or maybe you can. Although actually, I can't think of an example of anyone who's actually capable of doing what you're doing from an engineering point of view, who also can do impressions of various personalities or whatever. So don't worry about it. I've found it very interesting, and that's the main thing, because I do this podcast for my own personal benefit. No one else. I don't care about anyone else. Thanks again. I feel like we're going to speak again at some point, but I think we've covered all that we can cover at the moment. On the website, we will have links to Cody's website, of course. Thanks again, everybody. We'll be back in a week or two with another episode. Thanks again. Talk to you later.